All right, welcome to the fourth video lecture, this one on Pavlovian conditioning. We are going to cover a few basic topics on Pavlovian conditioning, but before we go there, I'd like to talk a little bit about uh, a non-associative process called sensitization. And this is important because we need to distinguish between Pavlovian conditioning from sensitization. And the simplest way to think about sensitization it is as the flip side, the opposite process of habituation. So it is an increase in responding due to repeated presentation of a stimulus. Recall that habituation was the decrease in responding due to a repeated presentation of a stimulus. So if we let me see. So if we represent the presentation of a stimulus of the same intensity, this being time, so we present the same stimulus over and over. Initially, this stimulus may elicit a response, may elicit a relatively small response, but over time it may elicit a stronger and stronger response. Typically we would see that in the form of if this is trials, that is presentations of the stimulus, and this is the magnitude of the response, we will see that it starts relatively with a low magnitude and asymptotes at some level that it's the maximum intensity of the response. So this would be a case of sensitization. Now, keep in mind though that this is still like habituation. This is not non-associative learning. There's no association involved. The change in behavior happens only because of the repeated presentation of a stimulus. So let's contrast that against Pavlovian conditioning. In Pavlovian conditioning, for the most part, we're going to be talking about increases in responding, like in sensitization. It's an increase in responding. But the increase in responding that happens in Pavlovian conditioning is very different. It's for a very different reason than in the case of sensitization. Let me write this down so that we don't get confused. Here we're talking about sensitization. Here we're going to be talking about Pavlovian conditioning. Just a warning, Pavlovian conditioning doesn't only involve an increase in responding. A decrease in responding can also happen because of Pavlovian conditioning. But that is going to be part of the advanced topic of Pavlovian conditioning, and in particular that's going to be part of what is called condition inhibition. We're not going to be talking about condition inhibition today, so we're going to be focusing essentially on the increase in responding, or otherwise known as excitatory conditioning, that is typically associated with Pavlovian conditioning. All right, so we're saying that both in sensitization and in Pavlovian conditioning, we typically see an increase in responding. Sensitization is part of the definition of what sensitization is. In Pavlovian conditioning, we also typically see an increase in responding, but for a very different reason. Let's draw the stimulus response relation this way. This is similar to the one that we see in sensitization habituation. In fact, this is the kind of relation that we see in any kind of elicited behavior. There's a stimulus that elicits a response, and because there is no requirement of any particular history, any particular learning involved in this response being elicited by this stimulus, we're going to call this the unconditioned stimulus and the unconditioned response. Why unconditioned? Because for the stimulus to elicit this response, it is not conditional on any kind of training. So you can think of food in your mouth eliciting salivation. You can think of any of the reflexes we saw before. They don't require any learning. Alright? Now the interesting thing is that, but this is not really what we're interested in Pavlovian conditioning. What we're interested in is another stimulus eliciting another response. One response, this response requires, for this response to be elicited by the conditioned stimulus, it requires a very particular history, an associative history. That's why Pavlovian conditioning is known as a type of associative learning. Right? So because this stimulus, the elicitation of this response by this stimulus is conditional on a particular history, on a particular learning, on a particular experience, we call this the conditioned stimulus and the conditioned response, right? So what is the type of experience that an organism needs to have for a conditioned stimulus to elicit a conditioned response? Well, for that to happen, the conditioned stimulus needs to be paired with the unconditioned stimulus. We'll oftentimes refer to that not as being necessarily paired, but as being contingent to. That is, the two things need to happen in a correlated way. And we're going to signify that with this bracket. That bracket indicates that the CS and the US are not presented independently. When one is presented, the other one is likely to be presented too. Right? And when we get that, when that happens, the conditioned stimulus may start eliciting a conditioned response. Notice again that initially the conditioned response during training, the conditioned stimulus does not elicit the conditioned response. And over time, so let me graph this here. This is trials. This is magnitude of the CS. Initially, before any learning has happened, before enough of this, before the animal has learned the association between these two stimuli, we may see very little responding to the CS. I'm sorry, this is CR. We see in trials are presentations of the CS. Initially, the CS does not elicit the CR, but over time, we'll see that it comes to elicit the CR. Notice that this graph is very similar to the sensitization graph that I drew before. That's why it's so important to distinguish Pavlovian conditioning from sensitization. because during sensitization, this increase in responding is only due to the presentation, to the repeated presentation of the stimulus. Whereas in Pavlovian conditioning, this increase in responding is not due just to the repeated presentation of the stimulus, of the conditioned stimulus, but of the repeated presentation of the conditioned stimulus contingent on the unconditioned stimulus, paired up with the unconditioned stimulus, shown together or shown one right next to the other. Alright, let me show you some examples. I'm going to erase part of this. And in each example, it is a good idea, it's a good practice to try to identify the different elements of Pavlovian conditioning. So what the CS is, what the US, the CR, and the UR, we'll refer to those as shorthand for conditioned stimulus, unconditioned stimulus, conditioned response, unconditioned response. It is very important that when you that by the end of this topic, you should be able to identify immediately upon an example of Pavlovian conditioning. You should be able to identify the CS, the US, the CR, and the UR, and you know what each of these things are. So, in the most typical example of Pavlovian conditioning, conditioned salivation, is the example of Pavlov's dog. So Pavlov's dog is presented with a tone right before food is presented and is introduced into the mouth, or food powder is introduced into the mouth of the dog, and so. And what that comes to elicit, that tone, by virtue of its pairing with the food powder, it comes to elicit salivation. So the US is the food powder, the UR is salivation, the CS is the tone, and the CR is also salivation. Because of the pairing of tone and food powder by itself unconditionally elicits salivation. The tone does not elicit salivation by itself. It comes to elicit salivation by virtue of its pairing with the food powder. This particular example often confuses people because makes people think that the conditioned response is the same as the unconditioned response, and that is not necessarily the case. I'm going to show you another example that illustrates this. Well, actually this one doesn't illustrate it that well, but it's another example of Pavlovian conditioning. Conditioned eye blinking. What that involves is presenting you with a puff of air onto your eye, and that elicits blinking, right? And that's completely unconditional. If I blow a little bit of air into your eye, you will blink. But I can precede that with a tone, a mild tone, one that initially does not elicit blinking, but over time, by virtue of its pairing with a puff of air, this also comes to elicit blinking. As I said, this is another example where CR and UR are very, very similar. But take the case of fear conditioning. This is one example CR and UR do not look similar at all. And actually, this example also highlights the relevance of Pavlovian conditioning in learning in general, in many important aspects of daily functioning. So suppose I present to you a fearful stimulus. Let's say to a rat, that may be mild foot shock. Mild foot shock. What that elicits is a sort of startle response, or jumping. You can see in some of the videos that we've seen in class, when the animal gets a mild foot shock, you see a jump response, right? Then, and this may apply to any other fearful stimulus if you're thinking about the case of humans. Now, suppose there was another stimulus that was paired with foot shock, was presented just before the foot shock. Let's say something like, oftentimes we use tones, because tones, auditory stimuli, oftentimes does not elicit a very, a very specific motor response. So tone is unlikely to, a mild tone, it's unlikely to elicit a startle or jump response. Now, what happens with the tone is paired with foot shock. What happens with the tone is predictive of foot shock. You get a fear response, which is not to startle, it's not to jump. In the case of the rat, it is what we call freezing. The animal stops moving, stays in place. You only see it breathing. It looks like a fear response, an anticipatory response to the foot shock. And that tells us that the animal has learned the relationship between, or the association between, tone and foot shock. The tone is predictive of foot shock. Another interesting example is taste aversion. Let me erase this. In taste aversion and preference, this works both ways. What we have is a particular taste. I'm going to give you the example of taste aversion first. So you have a particular flavor. Oh, sorry. You have a particular component of food. We're going to call it some sort of poison, mild poison, nothing that will kill you, but enough to make you sick, to have a sickness response to it. Lithium chloride is often used with rats. When humans, think of eating expired food. You eat something that has gone bad, and you get a particular response that will describe it as sickness. Now, typically when we eat something that has expired, it has a particular flavor. And that flavor becomes associated with poison. It becomes associated with the US that elicited the sickness response. And the conditioned response that we observe is a rejection of that flavor. Right? So again, conditioned response and unconditioned response are very different. But the only reason why the CS, the flavor, elicits rejection is because that flavor has been associated with a particular component of, of food associated with that flavor that elicits sickness response. This also works with taste preference. If instead of a poison is a nutrient that elicits a particular physiological response, and if there's a flavor that is associated with that nutrient, you'll see a preference for that flavor. High fat, high sugar, those kinds of flavor associated with high calorie content, those usually, the flavor by itself may not elicit approach, but with with pairing of flavor and nutrient, we may see that that you may develop a preference for that flavor. All right, I think I have one last example, sign tracking, but I'm going to skip this one because I'm going to show you a video in class about sign tracking. But I'll tell you very briefly about what it is. Essentially, if you have an appetitive stimulus, something that you normally approach, or the animal normally approaches, as a US, so that the approach response is unconditional to the presentation of that US, then what may happen is that CS's other stimuli associated with that appetitive stimulus may elicit approach 2. So this US may be food, for instance, for an animal, which elicits, for a hungry animal, elicits approach in an unconditional kind of way. And so if the CS stimulus that is associated with food, what we may see is a conditioned approach to this stimulus. The stimulus by itself initially may not elicit approach, but by virtue of being paired with another stimulus that does elicit approach, like food, then approach may be trained or maybe conditioned to this CS. Well, I'll show you some examples in class to clarify this particular phenomenon of sign tracking. Also goes by the name of auto shaping. Alright, let's talk briefly about some properties of Pavlovian conditioning. The first one is extinction. What that means is that if if I train this association between CS and US, and I eliminate the US, then of course that eliminates the UR, but it also, over time, if I present the CS by itself, the CR will also go away. However, similar to what happens in habituation, we often observe spontaneous recovery. So that following extinction, let me do this again. Following extinction of the US, in presentations of the CS by itself, what we may see is a decline in the condition responding. Let's draw that, probably helps. So these are CS presentations or trials without the US, and what we may see is this is the condition response, the magnitude of a condition response, or the probability of the condition response, and we may see over consecutive trials this CS declining in its ability to elicit a condition response. But if you leave a break, if you don't present the the stimulus for a while, you present it much later, you may see a little bit of recovery. And you do it again, and it declines again. Alright? Spontaneous recovery, very similar to what happens in habituation, but here is for a very different reason. And also, like in the case of habituation, we also see stimulus generalization. And in this case, we are referring to, let me erase this. We are referring to generalization of the CS. If you train a CS-US association and you present a slightly different CS, one that is similar to the original one but not exactly the same, you'll see that that CS may also elicit a conditioned response. Maybe a weaker one because not exactly the same one that was originally trained, but still you may still observe a conditioned response under those circumstances. And you may also see stimulus discrimination. That is, if you explicitly train two similar stimuli, one that we're going to call the CS plus. Oh, let me put this here. One that we call the CS plus, pair with the US, and the CS minus pair with no US. So it's not really paired with the no US, not paired with anything in particular, certainly not with the US. If you alternate between presentation of these two stimuli, even if the two stimuli, CS minus and CS plus, are relatively similar, what you may see is that the CS plus comes to elicit the CR, and the CS minus does not elicit the CR. So we say that the CS plus, the CS minus are being distinguished by the animal. Alright, let me erase this. Let's talk about what, finally, last topic for today, what makes a CS particularly effective. And the first characteristic, which should be somewhat obvious, is the salience of the CS in the US. If in taste aversion, for instance, the flavor is really mild, well, you're not necessarily going to develop an aversion towards that flavor. If it was a strong flavor, that's more easily trained, and you may develop a strong aversion towards that flavor if paired with poison or paired with food gone bad. Right? Also, if the US is weak, you may not develop a strong aversion. So maybe the poison wasn't that much. It didn't make you that sick. So it doesn't matter how strong the CS may be, how intense it may be. If the US is not very strong, if the poison is not very effective, well, you're not going to develop a strong aversion towards that CS. Now here's a critical one. Another characteristic of Pavlovian conditioning that may make a CS particularly effective at eliciting the CR, and that has to do with the timing of the CS relative to the US. And here is where we talk about, in the textbook it refers to 5 different types of conditioning. Trace conditioning, actually 4 different types of conditioning. Trace conditioning, delay conditioning, simultaneous conditioning, and backwards conditioning. Think of it logically. If this is that doesn't look like a straight line. if we represent the presentation of the US this way, so this means US is not presented, US is presented, US is not presented, and this is time, of course, moving from left to right. So there's no US, US on, US off. Think about the different ways in which the US could be presented with relation to the US. One way is the US is presented way before, the CS is presented way before the US. And so in that case we're talking about trace conditioning. And the interval between CS offset, turning off the CS, and turning on the US, referred to as the trace interval. This is not very effective. This does not make the CS particularly effective. The longer this trace interval, typically the weaker the conditioning, the weaker the condition response that is obtained to the CS. Alright. Another way in which CS can be presented in relation to the US is immediately before. So that CS offset and CS onset and US onset coincide, or maybe even overlap a little bit. In that case, we're talking about delay conditioning. And this is typically the most effective way of training a CS. You get a strong CR. Notice one thing. In this case, the CS is predictive of the US. It's telling you when the US is going to start in a very effective way. So, and this is probably what makes delay conditioning particularly effective. Now, here's another possibility. CS and US fully coincide, which case we're talking about simultaneous conditioning. CS and US presented exactly at the same time. Not particularly effective. Not particularly effective. Because if you think of the CS as a predictor of the US, well, in this case, the CS is being presented exactly when the US happens. It's not giving you a warning. Think of the US, of the CS as a warning signal. It is not a very effective warning signal, one that happens exactly at the same time as the thing that is you're being warned about. If this is so if this is supposed to warn you that a fire is about to happen, and this is the fire, well, it's a lot more effective when it's presented right before the fire instead of during the fire. Right. Last variety of conditioning that we may observe of course is backwards conditioning. Backward conditioning, in which the CS is presented after the US. Again, not particularly effective. Actually, pretty ineffective. If anything, the CS is telling you about the absence of the US. And you may get something that we're not going to discuss right now, but in the as part of the advanced topics, which is condition inhibition. The CS is telling you about is telling you that the US already happened. Not a particularly effective warning signal. last property of the CS and US that is important to take into account to establish the effectiveness of the CS is the contingency between CS and US. What do I mean by that? Think of contingency as a correlation between the presentation of the CS and the US. If the US is presented if the US is presented if the US is presented only a few times, and the CS is presented every single time before the US is presented, then the CS is a very effective predictor of the US. There's a high contingency. It's a high positive contingency between CS and US. On the other hand, you may have the US being presented all the time and the CS being presented all the time, but the CS may not be predictive of the US. They're presented randomly, independently of each other. Sometimes they coincide, but just by chance. In that case, the CS is not a very effective predictor of the US. So think of it this way. Think of what is the probability of the US given that the CS was presented, and think about what is the probability that no US is going to happen if no CS is presented. To the extent that this probability is high and that this other probability is also high, that means that there's a close pairing between CS and US, because the US happens when the CS is present and the US doesn't happen when the CS is absent. High positive contingency. That makes a CS particularly effective. In general, the rule of thumb is you want to ask yourself about to establish the effectiveness of a CS is how predictive is the CS of the US. And that ends today's lecture.